So, NVIDIA's latest keynote? Wow. It wasn't just about faster chips, not by a long shot. It was really a blueprint for a whole new industrial revolution. In this explainer, we're going to break down Jensen Huang's vision and really explore how they're building the engine of our AI future.
And, this quote from Jensen really just nails the vibe, right? It perfectly captures the shift. AI has gone from this kind of niche Woodstock moment to the Super Bowl, a massive, global, main event. And yeah, the hype is absolutely huge. But as we're about to see, the technology they're actually building is even bigger.
All right, so here's our game plan. We'll kick things off with a new age of AI that's making all this change necessary. Then, we'll dive deep into Blackwell, the hardware that's being built to meet that crazy demand. After that, we'll look at the software that makes it all work, see where all this power is actually being used in the real world, and finally, we'll look ahead at the massive trillion-dollar plan for what's coming next.
Okay, so let's dive right into the big picture, the new age of AI. The really key thing to get here is that we're moving way beyond AI that just spits out an answer. We're stepping into an era where AI can actually, reason its way to a solution.
And this brings us to the core idea here, agentic AI. Think of it as an AI that has agency. It doesn't just respond to a question, it perceives a situation, it reasons about it, it makes a plan, and then it actually acts on that plan. So instead of just telling you the best flight, it could go out, use tools to browse different websites, and then actually book the flight for you. It's a real problem solver, kind of like a human assistant.
This shift really puts the whole history of computing into perspective. For the longest time, it was all about retrieval computing. You search for a file, it finds it. Then came this amazing generative era, where AI could understand context and create a brand new answer. Agentic AI is the next and much, much bigger step in that evolution.
So you might be wondering, how does an AI actually do that? How does it reason? Well, it's through a process that people are calling chain of thought. Instead of just blurting out a single answer, the AI breaks the problem down into little pieces. It generates tokens. You can think of them as little bits of digital thought for every single step of its reasoning process. It even checks its own work and tries out different paths before it puts together the final and usually much more accurate answer. And here's the kicker, the big so what of all this. All that deep thinking, generating all those extra thought tokens, it is incredibly expensive from a computing standpoint. We're talking about a 100 times increase in the computing power needed, and that's just compared to last year. That's a massive, massive challenge. Right, so how on earth do you solve a 100x compute problem? Well, that brings us to our next section. Let's talk about Blackwell, the engine of what Jensen is calling the AI factory. And this AI factory idea, it's really the key metaphor for everything. Data centers aren't just for storing our photos anymore, they're becoming actual factories that manufacture intelligence. Think about it. The raw material is your data. The product, that's intelligence, generated as tokens. And when intelligence becomes a manufactured good, the efficiency of your factory is everything. And just like any real-world factory, you've got this classic trade-off. Do you focus on making one thing super fast for one person, that's low latency, or do you try to serve millions of people at once, that's high throughput? For an AI factory, it's the exact same problem. Do you give one user a super fast, brilliant answer, or do you generate tokens for millions of users all at the same time? And this is where Blackwell comes in. It's the answer to that trade-off. For those really complex reasoning models we were just talking about, this new platform delivers, get this, a staggering 40 times performance increase over the last generation. And you got to understand, this isn't some small incremental update. We're not talking 10 or 20% here. Look at this chart, going from 1x to 40x in just one generation. It's a revolutionary leap. This is the kind of jump you need to make these AI factories actually work, to make them economically viable on a global scale. But having all that insane hardware power, it's really only half the story. Which brings us to our third section, the software secret sauce. What NVIDIA is calling the operating system for intelligence. See, the thing to remember about NVIDIA is that their dominance, it isn't just about the silicon. It's about decades of them investing in the full software stack, all the libraries, all the frameworks that developers have come to rely on. It's that deep, deep integration that really unlocks the true power of the hardware. And right at the heart of all this software is something called NVIDIA Dynamo. You can think of it as the factory's foreman, or maybe the conductor of an orchestra. It takes thousands of these individual GPUs and gets them to work together like one single giant computer, constantly shifting jobs around to squeeze out every last drop of performance and efficiency.
All right, so we've got this mind-boggling amount of compute power, all managed by some incredibly smart software. So what do we do with it? Where does all this generated intelligence actually go? Well, that leads us right into Section 4, from enterprise to robots.
You know, for the longest time, if you wanted to play with cutting-edge AI, you had to be one of the huge cloud companies. That's it. But that's all changing now. The technology is getting to a point where huge global enterprises in finance, in healthcare, in manufacturing can start building their own custom AI factories. But this all leads to the next huge frontier. See, everything we've talked about so far, it's all happening inside a computer, in the digital world. So the big question is, what happens when that intelligence needs to step out and operate in our physical world? Well, the answer is what we call physical AI. This is AI that actually gets the laws of physics, stuff we take for granted, like gravity, friction, or knowing that an object is still there even when you can't see it. That kind of fundamental understanding is the key that's going to unlock the next generation of robots.
And believe it or not, this isn't some sci-fi future. It's happening right now. NVIDIA announced Project Groot, and yeah, that's what it's called, which is basically a foundational model designed to be the brain for humanoid robots. It learns from tons of simulated data, all with the goal of creating a general-purpose intelligence that can be plugged into almost any robot.
Okay, so to wrap this all up, let's zoom out and look at the long-term vision. This is Section 5, the trillion-dollar roadmap. It's the blueprint for the next decade of computing.
What is just wild about this timeline is the sheer relentless pace. Blackwell is just now hitting production, but they've already announced the next platform, Rubin, for 2026, and Rubin Ultra for 2027. I mean, a one-year cadence for a new platform, that's unbelievably aggressive. It just screams that this is an all-in, long-term strategy.
And this quote from Jensen really puts the economic scale of this whole thing into perspective. The amount of money needed to build out these AI factories is on the same level as a new industrial revolution. I mean, we're literally talking about a $1 trillion infrastructure build-out to create the factories of the 21st century. And all of this leaves us with one final kind of mind-bending question. The first industrial revolution gave us factories for things like textiles and steam engines, and it totally reshaped society. So if these data centers are the new factories, what are they going to build? What kinds of discoveries, services, and products are they going to generate that right now, today, we can't even begin to imagine?